Hello, children. Welcome to Right Tuition Classes. We are doing challenging lecture number 3, challenging questions of circle. Now, on question number 7, children, what is given? Segment AP is a tangent. Segment AP is a tangent. Segment AP is a tangent. The moment they talk about the tangent, children, like I taught my students at least, एक ही tangent है. Picture में एक ही tangent है. Segment AP is a tangent. जैसे tangent, tangent का theorem तो है, tangent is perpendicular to radius. जब एक theorem रहेगा, अरे लेकिन इधर center का सवाल ही नहीं आता. That means ये theorem tangent is perpendicular to radius हम लोग यूज ही नहीं करेंगे. Center of the circle is not mentioned. फिर एंगल का क्वेश्चन है. यस, सर्कल आर्क में यू लर्न चिल्ड्रन angle between a tangent and a chord. Can you see this angle between a tangent and the chord is always equal to the angle the chord subtends in the alternate segment of circle. I mean this angle, can you see this tan secant angle? Okay, and this inscribed angle, can you see here? They intercept the same arc. Are you getting me here? We say both these angles are congruent. तो एक ही tangent दिया है, सेंटर तो मार्क्ड ही नहीं है, तो tangent is perpendicular radius आएगा ही नहीं. फिर भी मुझे इसको तो यूज करना है. ओके, एक tangent दिया तो मुझे यूज तो करना ही पड़ेगा. So let's see this sum. Children, what is there? Okay, what is given to us? All can understand. Okay, you can see here. I want to prove this angle BPD. Can you see this red angle? Okay, I want to show this angle BPD. Red angle is half. Okay, half this big dark green angle ABP minus this blue color angle. Okay, the blue color angle APB. Oh, these three angles are involved. These three angles are involved. Okay, these three angles, the green angle, the blue angle, and the red angle. So among these angles, please have a look at children. You give a thought. कौन सा angle कोई theorem में get involved? Yeah, this angle is getting ABP. If I want, ABP is an exterior angle of triangle PCB. Angle ABP, just have a look at this proof, children. Suppose I want this angle ABP. I think I'll start with this angle ABP. Okay, I'll start this angle proof. I'm going to start with angle ABP. Just have a look at angle ABP, children. Okay, ABP is an exterior angle of triangle PBC. अरे बच्चे लोग सबको मालूम है. देखो ट्रायंगल पीबीसी, देखो उसका साइड सीबी हैज बीन प्रोड्यूस्ड. सो दिस ग्रीन एंगल इज फॉर्म्ड. इसको क्या बोलते हैं? एक्सटीरियर एंगल ऑफ अ ट्रायंगल. So whenever extra angle is used, extra angle is always equal to sum of the remote interior angles. So this is at vertex B. This exterior angle is at vertex B of triangle PBC. So the angles at the other two vertices of the triangle, they become the remote interior angles for this extra angle. The extra angle is always equal to sum of the remote interior angle. And the angle ABP equals angle CPB plus angle, please have the extra angle is equal to angle CPB plus angle PCB. Okay, plus angle PCB. I call this as statement number 1. This is called remote interior angles theorem. React. Okay, remote interior angles theorem. Remote interior angles theorem. And now you can just check here, children. You want ABP in your answer. You don't want CPB in your answer. But CPB can be related to the red angle which I want. The red angle ABP I want. Sorry, the red angle is what, children? PPD I want. So your angle CPB, you can see here, children, is twice angle BPD. That means in place of this angle CPB, I can always put a twice angle BPD because BPD answer में मांगता है. Okay, BPD answer में मांगता है. So this angle CPB is twice angle BPD. Reason, you can write ray PD bisects bisects angle CPB, children. Bisects angle CPB. चलो ये मतलब इसका जगह में आ जाएगा ट्वाइस BP, लेकिन PCB भी नहीं मांगता है, PCB भी नहीं मांगता है. We don't want this PCB. We don't want this PCB. You can see this PCB blue color angle. I don't want. Hey, but don't you agree? This blue color angle which I have got, okay? What is that angle PCB? Can you see this angle PCB? Yeah, sorry. I'm so sorry. This angle PCB, you can see, is related to this blue angle APB. Don't you agree? Angle between a tangent and a chord. Angle between a tangent and a chord. PB is a chord. AP is a tangent. Angle between a tangent and a chord is always equal to the angle the chord subtends in the alternate segment of the circle. PB subtends is angle PCB. So naturally, this angle PCB, what is this angle PCB, children? Angle PCB equal angle PCB is equal to angle APB, can I say, children? Reason angles in a alternate segment. What do you call it? Angles in a alternate segment. Angles in a alternate segments. We call this theorem as angles in alternate segments. Okay? The angle between a tangent and a chord is always equal to the angle the chord subtends in the alternate segment. Both these blue angles are equal. So I don't want this PCB. So I wrote PCB first. What is this PCB equal to? This PCB is equal to APB. So I think I can change this. Okay? I can change this. What you have put in blue. Can you see here? I can change this PCB to APB. I think I'm going to do that now. You can see here, children, what is going to happen that will rewrite this angle ABP you want. ABP equal. You don't want CPB. What is CPB? Twice angle BPD. Plus, you don't want angle PCB. What is PCB equal to angle APB? And the reason is from 1, 2, and 3. And now I think only arrangement, children. You want twice BPD अकेला. तो APB उस साइड जाएगा तो क्या होएगा? माइनस होएगा. तो angle ABP minus angle APB is equal to twice angle BPD. But I want BPD alone. So naturally this 2 will come down. So it will become half. Okay, and it will become ABP minus angle APB. Don't you agree, children, that 2 will come down, okay, as half. ABP minus APB equal angle BPD. I think I got my answer. This is the answer what I want. You can see a BPD equal half ABP minus APB. I think I got it, okay? Now the second part, this was the first part of the proof. Now the second part of the proof is, I may have to rub it off, children. I want to prove this PA. Can you see this PA, children? I want to prove this PA. Okay, what is PA? I'll just show you this color, okay? This color, this PA, the pink color segment. Can you see this pink color segment, children? This pink color segment, okay? This pink color segment, you can see here. I want to show it is equal to, this pink color segment is equal to this pink segment. I want to show both these pink segments equal. That means, when can you say two segments? That two, if they belong to the same triangle, there's only one method left. Both of them belong to same triangle, APD. That means I want to show this pink angles equal. This is APD and ADP I want to show equal. So how can I go about children? Very easy. Just try to show these angles equal. So simple, children. You can see here, I want people to pay attention here. Can you see this? APD, okay, is made up of, okay, I'll put it like this. I'll show you like a separate proof, okay? This angle, blue angles are equal. Blue angles are equal. So let them be equal to Y. And these two angles, BPD and CPD, be equal to X. So please have a look here. I'll rewrite, okay, angle. I don't want to continue with this proof. I want to take it as a different proof. See here, angle A, I'm so sorry, children. I don't have place to write, but I know what I want to prove. Okay, So shall I rub this question better? I want to prove this AP and AD equal. So what I do, very simple way I want to follow, okay? I know I'm going to rub this given information because I know everything now. I'll just tell you, children. I'll also remember, okay? Do not worry about it. Question is not there. Oh, how the sir is going to show. Just have a look at it. So easy, children. The angles which are equal, okay, you just mark them as variables, okay? You can see here, children, angle, what I'll do, angle APB, okay? Angle APB, can you see this APB? Angle APB is equal to angle PCB. Can I write angle C equal to X degree? Okay, reason angles in alternate segment. Angles in alternate segments. Angles in alternate segments. Okay, angles in alternate segments. Then which other angles are equal? Angle CPD equal angle BPD equal X degrees equal Y degrees. Let us take Y degrees. Reason, children, ray PD bisects angle BPC. Hey, now you get your answer, children. So simple. Come on. You get your angle APD. What is APD equal? Angle APD equal. Suppose I call this as, we continue with this, okay? Statement number 4. I call this as statement number 5. Okay. Now angle APD equal, angle APD equal, angle APB, angle APB plus angle BPD, angle addition property, angle addition property, angle addition property. And now put the values, children, whichever angle you know this. Therefore, angle APD equal, what is the value you can see here? APB is, you are taken APB as X, okay, and you are taken BPD as Y degree. Okay, I call this as state number 4, 5, 6. The reason is from 4 and 5. Okay, so angle APD equal X plus Y, okay, from 4 and 5. Okay, now look here, children, you want ADP. Angle ADP is exterior angle of angle ADP is exterior angle of triangle PDC. Just have a look at triangle PDC. Therefore, angle ADP, exterior angle, is equal to sum of the remote interior angles. Angle CPD plus angle C. I call it as remote interior angles. Remote interior angles. Remote interior angles. Do you know the measure of these angles? Yes. Therefore, ADP equal, what is CPD, children? CPD, you can see Y degrees. And what is C? Angle C equal, children. You can see this angle C on top. You can see this X degrees. Okay. I'll just say again from 4 and 5. And now please have a look here. This is your statement number 7. Now both these angles you can see here, children. I'm going to rub off more space is needed. Okay, you can see here. Now what will happen, children? So simple, the question is become. Therefore, in triangle APD, angle APD is equal to angle ADP. Angle APD is equal to angle ADP. Can I say from 6 and 7? Both are X plus Y. Therefore, what I get, children? AD is equal to AP by converse of isosceles triangle theorem. I'm so sorry, children, I had to rub off this question, but I'm sure you'll be able to understand this sum, okay? Not a difficult sum at all, children. You can do it. It's not so simple also, but if you concentrate, You'll get it. Okay, children? Given chords AB and CD, chords AB and CD of a circle. This is my question number 8, children. My question number 8, okay? Now look here, very simple. Chord AB and chord CD intersect each other at point M. Chord AB and CD intersect each other at point M. Chord AB and chord CD intersect each other at point M. Then they give us P is the center of the circle. P is the center circle. Then they give us radius of the circle is 13. Radius of the circle is 13. And they give us PM is 5, children. This PM equal 5. Radius of the circle is 13. And this PM is 5. And they want me to find this CM into DM. CM into DM. So what am I going to do? Very simple. I extend this PM on both sides. I extend PM on both sides to intersect each other at X, to intersect the circle at X and Y. So see the construction, children. Construction is I extend segment PM on either side to intersect the circle at points X and Y, at points X and Y, at points X and Y. Okay, what I do, I extend segment PM. Okay, extend PM to intersect the circle at points X and Y. Now tell me, in this segment, which all, on this new segment, sir, which all segments you know? Yeah, I think I know. What is the center of circle P? So I know PX equal PY equal 13 centimeter. Okay, this is radius of the same circle. Any other segment is known. Just have a look here. Radius of same circle, radius of same circle, radius of same circle. Px equal Py equal 13. Any, yeah, PM is given as 5. PM is given as 5 centimeter given. So do they agree, children? Just have a look. From P, can you see this P, children? From P to Y, Py is 13. A part of it, PM is 5. So what is Ym equal? So Ym equal, children, Py minus PM, P dash M dash Y. So Py equal, children, Py equal, what will I get, children? Py. So Py, sorry, Ym equal Py minus Ym equal, I'm so sorry, children. Ym equal Py. I'm finding Ym, children. I'm finding Ym. Ym equal Py minus PM. So Py is 13, children, minus 5. How much you get? 8 centimeter. Why did I find 8 centimeter? Okay, now tell me, can you see Ym, children? Ym. Okay, I'm talking about, this was XM, children. I'm so sorry, children. This was XM. XM equal PX minus PM. PX minus PM. PX is 13. Okay. Now just have a look at Ym. Ym equal, children, Py plus PM. The reason is M dash P dash Y. Okay, and here it is P dash M dash X. Okay, now what will happen, children? Here, this becomes Py is a radius. Radius is 13 plus 5. How much you get? 18 centimeter. And now very simple, children. You can see here your chord CD. Just have a look at chord CD. Chord CD and chord. Chord CD and chord XY. A diameter is nothing but a chord, okay? XY intersect at point M inside the circle. So naturally, children, inside the circle, whenever you see two intersecting chords inside a circle, you can use intersecting chord properties. What is that? That is, please have a look at this. CM into DM. Chord CD ka CM into DM. Therefore, CM into DM is equal to what? It will be XM into YM. XM into Ym, and I can call it as by intersecting chord properties, by intersecting chord properties. By intersecting chord properties. By intersecting chord properties. So what I'll get? Cm into dm equal, children, Cm into dm equal xm, and which is xm I'd got. You can see a xm I'd got it as 8 children, 13 minus 5. How much I'd got ym? 13 plus 5, that is 18 children. So this is 144 square centimeter, children. Okay, I hope people understood this. A totally different type of proof, but very simple, very easy, and very effective. Okay, now we go to another question, children. A little more tougher. Okay, we'll see this. It is little tougher than the normal sums. Okay. Now, in the above figure, a semicircle with its diameter on the hypotenuse. You can see a semicircle, children. Doesn't look like, but I tried my level best. A semicircle with its diameter on the hypotenuse is seen touching the remaining two sides. Is seen touching the remaining two sides. दिख रहा है? एक right angle triangle है, एक semicircle है, semicircle का hypotenuse, semicircle का diameter is on the hypotenuse और ये semicircle बाकी दोनों sides of the triangle को touch कर रहा है, okay? और the center of the semicircle, okay, divides the hypotenuse into two parts of length 15 and 20, 15 centimeter and 20 centimeter. 15 AO is 15 centimeter, OB is 20 centimeter. AO is 15 centimeter, OB is 20 centimeter, and they want me to find the radius of the circle. ये circle का radius निकालना है. So when I think, children, radius, कौन सा radius है? Hey, you can see OD is a radius, children. OD is a radius. I join this. Hey, I see OE is the radius. I join this. So these dotted lines are my construction. Okay. What I do, I draw segment. Please have a look here. Draw segment OD and segment OD and segment OE. Now you want to find this radius. You want to find this radius. You want to find this radius, children. You want to find the radius of the circle. That means you want to find the length of, you want to find the length of OD or OE, okay? Now how can I get it? So if you take the radius as R, if you take the radius of the circle as R, so OE and OD will be equal to R. If you take the radius of the circle as R, then OE equal OD equal R. You want to find R. Got it? So what I realize, see, in mind, I'll just tell you, children, what the idea comes to your mind, how the idea comes to your mind. I see a right angle triangle, okay? I see a right angle triangle. And I see one side of this right angle triangle is R, okay? One side is 20. Suppose, I'm just giving an idea, okay? Suppose one side is 20, okay? And the other side is something like, please have a look here, like, like 3 upon 5, okay, 3 upon 4 R. Okay, so what are you seeing, children, in this right angle triangle? Two sides are in terms of R. Third side, I think I can use Pythagoras theorem and easily find the value of this R. I mean, I'm sorry, I said it to this. Okay, like suppose in this, that is a right angle triangle, okay? In this right angle triangle, you see the hypotenuse is 20. And suppose you see this side is 3R upon 4. So two sides of a right angle triangle in terms of R and hypotenuse I know, third side I know. So I think I can use Pythagoras theorem, 20 square equal R square plus 3R upon 4 the whole square, and try to get the value of this R. I mean, I can get the value of R. Got it? So here also I can see a right angle triangle. And one side is 20, one side is R. So if I can find dB in terms of R, dB ka length in terms of R, I think I can use Pythagoras theorem and find the value of R. Like, how to find dB in terms of R? So what I realized, children, look at the big triangle ACB. Can you see? Suppose if I take this angle ACB as 90, okay? Once again, look at this right angle triangle. Two sides are in terms of R. Two sides of a right angle triangle are in terms of R. Third side, I know. Okay, so I can use Pythagoras theorem where R becomes the unknown variable. Today I can solve this equation, get the value of R. Now, how to solve it, we'll see later, okay? But right now I just say, So that same idea comes to my mind. Look at this triangle ODB. And I see angle ODB is 90 by tangent is perpendicular to radius, tangent theorem. That means a right angle triangle, उसका एक side 20 है, दूसरा side R है. So तीसरा side, if I can get this third side in terms of, please have a look here, suppose this side BD, okay? If I get this side BD, okay, if I get this side BD in terms of R, then I can use Pythagoras theorem and get the value of R. And my aim is only to get this value of R, radius of the circle. So how do I get this in terms of R? So I realize just like this triangle, there is one more triangle, and that is also, please have a look here, you can see that is also a right angle triangle. So, and its one side is 15, other side is R. So I get an idea, can I get these two triangles similar? If I can prove both these triangles similar, then we know one thing, the corresponding sides are in proportion. The ratio of the corresponding sides will be in proportion. So I can, perhaps that will help me to get BD in terms of R. But then you can see only one pair of angles are congruent, one more pair is needed, then only I can say both these triangles similar. So how that is possible? So it's very simple. Why this big triangle is a right angle triangle? It has to help you. So just see a children solution, okay? I'll just not say solution, okay? You can see a children. I'll just say like this. First, angle AEO equal angle ODB equal 90 degrees, because I'm going to use this, okay? Reason by tangent theorem. Tangent is perpendicular to radius. I hope everybody knows that theorem, okay? Tangent is perpendicular to radius. So, this pair of angles can be said congruent. But we require one more. So now look at the big triangle, children. Look at the big triangle. See how I go about. In triangle ACB, can you see the big triangle? Angle ACB is 90. Angle ACB equal 90 degree, okay? Is given to us. But what way it is going to help me? Yeah, it is going to help me. Let angle B be equal to x degree. Got it? So when two angles of a triangle are known, the third angle can be found out by using angle sum property of triangle. So what is that? Therefore, angle, you can see here, DOB. The third angle is DOB. Sorry, the third angle of this big triangle is angle A. I'm so sorry, children. In triangle ACB. Angle ACB is 90 by tangent theorem. Angle B is x. So which is the third angle, children? Therefore, angle A equal 180 minus 90 minus x. This is remaining angle. What is the reason, children? Remaining angle of a triangle. Remaining angle of a triangle. And how much you get this, children? Just have a look here. So angle A, you get it as 90 minus x. And I'm going to use this. This is my, suppose, statement number 2. Okay. Now, this angle, okay. This angle A, I got it. But angle A, kaisa help karega? Look, angle A belongs to triangle AEO. So look at this triangle AEO now. In triangle AEO, again you can see angle AEO equal 90 degree by tangent theorem. By tangent theorem. And you can also see its angle A is a common angle. Angle A equal 90 minus x. Can I say from 2? If two angles are known, how do you find the third angle AOE? So therefore, angle EOA, I'll call it as EOA equal 180 minus 90 minus x. And I'll write the reason, remaining angle of a triangle. Remaining angle of a triangle. And how much I get, children? When you open the bracket, I think the space will not be sufficient, but anyhow, when you open the bracket, how much you get, children, here? You can see here, therefore, angle R will be equal to angle EOA. Angle EOA will be equal to 180 minus 90 is 90. 90 minus 90, 0, 0 plus x, that is x degrees, okay? I hope people are understanding EOA equal x. I call this as statement number 3. Okay. And now you can see both the triangles, children. I think I can easily prove them similar because this angle I got it as x. So look, only thing you should write the names in proper one-to-one correspondence. Okay. Like in triangle. Suppose AEO. I take this triangle's name first. In triangle AEO. And triangle. Look at the one-to-one correspondence. AEO. E is 90, D is 90. Angle EO is X, angle B is X. So naturally, if I say AEO, it has to be ODB in triangle OEB. Okay, AEO and triangle ODB. Angle AEO, congruent angle ODB. You can always say from 1. You have made it a point to get this. Okay, both are 90 from 1. And then you can also say angle EOA is congruent to angle B. Both are x degrees. You can see we have proved both are x degrees. Therefore, triangle AEO, similar triangle ODB by AA test of similarity. And once the triangles are similar, children, corresponding sides are in proportion A upon this A upon OD equal AE upon OD equal EO upon BD equal AO upon OB. Corresponding sides of similar triangles. Corresponding sides of similar triangles. Corresponding sides of similar triangles. Children, now we can put the values of AE. AE we don't know. OD we know R. And EO we know, children. EO we don't know. EO we know it R. Sorry, EO is R. Upon BD is how much we don't know BD. Got it? E is equal to AO. AO is 15 upon 20. So I was talking about 5 3s are 5 4s are. So I was talking about getting BD in terms of R. So BD equal 4R equal R upon, sorry, I'll get it here. So you can see here, children, R upon therefore R upon BD equal 3 upon 4, cross multiply. 4R equal 3BD. So BD equal 4R upon 3. So I think now I can use Pythagoras theorem in triangle ODB. In triangle ODB. In triangle ODB. Angle ODB equal 90 degrees. Angle ODB equal 90 degrees. Okay. Therefore, from 1 you can say, therefore, what is Pythagoras theorem, children? OB square equal OD square plus BD square. Can you see, children, by Pythagoras theorem? Please write full form, okay? By Pythagoras theorem. Now put the values, children. 20 square equal. OD is how much, children? R square plus 4R upon 3 the whole square. I think I can easily solve this equation. And how much I'll get, children? I'm going to rub the question, children, now. Well, I think question is the best thing to be rubbed now, okay? So I understood the question. We know the question, so naturally I'm rubbing it off. Now you can see here, children, what will happen? So 400 equal, come on, solve it already. 400 equal R square plus 16 R square upon 9. Got it? 400 equal, you can see here, children, what it will be? 400 equal R square
plus 16r square upon 9. Okay, now what is this? Cross multiply. So 400 equal 9r square plus 16r square. The whole thing upon 9. So 400 equal 25r square upon 9. So r square equal 400 into 9 upon 25. 25, you can see here, children, 25 16s are. So r square equal 144, r equal 12 centimeter. So radius of semicircle is equal 12 centimeter. I don't think it is difficult. There are many methods of doing it better. I could have used basic proportionality theorem. I could have proved this as a square, and this would have been R, children. Then I could have used basic proportionality theorem, and I could have got BD in terms of R, and then say, are you getting me here? That would have been more easier, I think. But then I wanted to try out a different method. Okay, you can see here what I did. I proved both these triangles similar. And from that I got BD in terms of R. Once I got BD in terms of R, I can use Pythagoras theorem and found the value of R. Very okay, looks simple. Okay, we go to the next sum, children. I think this lecture will